Okay, guys, so I had some complaints on the last one saying it wasn't very clear, and there was a point where things cut out and they couldn't hear what was going on. So I decided to re record this tonight. Luckily, everything was already written up here. And so we'll go through it real quick, and hopefully, this will be a little bit better. All right, so first of all, what we want to know is this is lesson 2, okay, unit 1, lesson 2, understanding rational numbers. All right. So what we need to understand here, because we're talking about rational numbers, is that we're going with that natural progression. Last lesson we talked about counting numbers, then whole numbers, then integers. Rational numbers are simply two integers that can be divided by one another. In other words, we look at division in a fraction form. Okay, so our essential question is, how are rational numbers written as decimals? We put them into a fraction, and then we go through and divide the numerator by the denominator, the top number by the bottom number, and that will give us the decimal. Okay, guys, and we're allowed to use a calculator with this, so make sure that you use one. So here's some examples that I wrote down. Okay, so first of all, we have 1/4, right? 1/4. You can probably just see my finger and that's it, but that's good. You can see the board at least. This turns into 1 divided by 4, okay? This equals, if you take a calculator and do it, 0.25 or 0 and 25 hundredths. Okay, this is what's known as a terminating decimal. When you punch it into your calculator, it gives you an exact answer. Okay, that is a rational number. Okay, another one that we know of is 2/3, 2 parts of 3. We go through and divide this. This is 2 divided by 3. And you'll notice that when you divide this in a calculator, you're going to get 0 and 666666666 all the way across. When it goes all the way across your entire calculator, that means it's a repeating decimal. Sometimes it'll end with a 7. That's just your calculator rounding it. Okay, guys? So the way we write this is we say 0 and 6/10 repeating. We put a reprehend over it. Okay, we put this repeating bar right there over the 6. Okay, guys? This means this is a repeating decimal, which is still a rational number because it can still be put exactly into a fraction form. Okay, guys? So the way I remember this is this. Rational number, the root word of rational is ratio. A ratio is a fraction. Anything that can be put exactly into a fraction is a rational number. Okay, so if that helps at all. All right, so we have some other ones where we have an improper fraction, 10/3. This equals 10 divided by 3. Now this is going to give us whole number and a decimal number, okay? So in other words, 33 and 3/10 repeating. If you go through and put this in the calculator, it's going to be 33.33333333 until the whole calculator is full. We know that that is a repeating decimal, okay? Then we have ones that are just a terminating number. In other words, a whole number. 100 divided by 5, 100 divided by 5. If you put that in a calculator, simply 20. Okay, guys? So that's what we're looking at so far. Now, what I want to show you, and I'm going to move this over so you guys can see it. So I'm going to kind of watch this. I'm going to go to the next one. Okay? So I want to look at some of the examples. All right? Okay, so example 3 gave us one here, and it got a little bit confusing. So what I wanted to do is show you different ones, okay? So in other words, if we have negative 6.382, in other words, a negative 6 and 382 thousandths, right? Then this is a rational number, okay? The reason it's rational is it is terminating. It's not repeating, and it's not infinite. It's terminating, okay? So even negative numbers can be rational, and it's a terminating number. It ends. It's exact. It ends. Okay, then B said, we have this one. Now, I'm not going to try to even say this one. I'm just going to say decimal because it's a long one. But 1.5399. Now, notice the repeating sign is only over the 81. Normally, we would write this without these other ones. But what this is saying is this 81 repeats over and over. We would actually take these off, and this is what it is. This is still rational. We can still put this into a perfect fraction, okay? A repeating decimal can go into perfect fraction. So this is rational, and it's repeating. Okay, guys? Now, this last one, though, is where we hit irrational numbers. Okay, and irrational numbers are kind of rare. Okay, so in other words, if I have a number like this one, 0.43524982 ... this means that it's infinite. Remember in those sets of numbers that we did in lesson 1, we had sets that had dots on either end. That meant it was infinite. This goes infinitely this way, and it's not repeating. This makes it irrational, and it's an infinite non-repeating number. Okay, guys? Another example of that is the square root of 2. If you put in the square root of 2 into your calculator, it's going to be an infinite non-repeating decimal. There's one that you know of that is irrational, and that's pi. 3.14 we use is a rounding of pi. We know that pi goes on indefinitely, okay, and it's non-repeating. That means that it's irrational. Okay, so let's go to our last example and see if this sheds a little bit more light on this, okay? So here's what we're looking at. Sorry, here's what we're looking at. I've got this number, and what I did was I used it every time except for I changed it just a little bit so you can see the difference. So you've got 6 and 235 thousandths. Now, if we just leave it like this is a terminating rational number. It can be put exactly into a fraction, so it's rational. However, I can just add a repeating sign over the 35, and this makes it a repeating number, but it's still rational. Any repeating number is still rational. It can be put exactly into a fraction form, okay? But if I take the repeating sign off of it and I put 2 points behind it, that means it's non-repeating and it's going on forever. That's your infinite non-repeating irrational number. So what I want you to do is make sure you pause this and write this down so that you can look at the differences between them. Do you guys understand? I want you to see those differences, okay? So let me look at my notes just to make sure. Yep, it looks like we got everything, okay? Now, one more thing. This is your bonus. Because you went through and watched the whole video, I helped you with one of them, okay? And that is quiz number 3, okay? So quiz number 3, well, quiz 2, number 3 within the quiz, is this one. It says it's 1 7/8, and they want you to turn this into a decimal, okay, guys? Now, here's what you have to understand. If you've got a whole number with a fraction, this is a mixed number, right? You've got a whole number sitting there, 1. That's going to be in front of the decimal. See how it's over here in front of the decimal? Okay. Then you take the fraction here and just do like we did with the fractions up here. 7 divided by 8. When you divide 7 by 8, you get 0.875. Just make sure that you don't write just the 0.875 and forget the 1. Okay. You got to combine those. So this becomes 1 and 875 thousandths. Okay, guys? So hopefully you're doing well with this. Make sure that you go over and take your notes, just like I do, right? We write our notes over on the left, and then we go through and we put our questions. Oh, sorry, am I doing this wrong? Yeah, on the left, and then do our questions on the right, okay? Make sure that you do the Excel and do all that before you come to class so that we can go through and answer any questions that you might have. All right, guys. Hope everything's going well. and I'll turn this off and I'll upload it here pretty soon, and hopefully it'll be better than the last.